Hi everyone, it's Tom from Coroutines here. This is the first video in a little tutorial series I'm going to put together about intermediate topics in C#. So today I'm going to talk about coroutines and animation. If you guys have any ideas of tutorials that you'd like me to do, then please fire them my way, either by email or Twitter, Facebook, or just in the comments below, and I will see what I can put together, because I'm more than happy to help. So coroutines today, specifically coroutines and animation, is what I'm going to show you, because I think the coroutines can really help you when you're animating anything really, but in this case we're going to actually be animating a rocket launcher. So to start off with, what is a coroutine? I'm sure most of you will know, but a coroutine is just a method, or technically a subroutine, which allows you to stop and start the execution of code by using a yield statement. And you can basically, that yield statement will allow you to pass through to the next line of code when a certain statement returns true or false, or a method completes. If you want more information about this, I think the website UnityGems is excellent for good Unity information. They've got some videos up there as well about coroutines if you're still confused. I'm going to be looking at animation, but they cover it in more general, more generality. So let's just see what we're actually going to be doing. It's a pretty bog standard rocket launcher, but the script that generates this is much easier because it was easy to write. Because of coroutines basically, and particularly one coroutine which I got off the UnityGems website. So you can see it's a firing animation and a reloading animation. If I interrupt the reloading animation by changing weapon, it will go back into it again. So this is the script that I use. There's a few, we initialize a few transforms and audio clips here to make it all run smoothly, which aren't really important. The most important thing is that this is just the update. This is the only thing. It's just 4 lines of code. Not even that if I wrote it a bit differently. But when we fire, and we're not firing already, and we're not reloading, then we're going to fire a rocket. And this is a coroutine that we're starting here. Unity has this specific function. And if we're not doing any of that, all we're going to do is we're going to wait for whatever animation we're playing at the moment to complete, and then we're going to play the idle animation. Now, let me just bring this up. This is the coroutine fire one rocket, and it's basically split into little chunks. And that first of all, we start a Boolean function which says that we are firing a rocket. Then this little block of code here instantiates the rocket and gives it a velocity and a direction. We play an audio clip of firing the rocket. Then we apply a bit of recoil to a root transform, which parents all of the weapons. And then this is the important bit. This is where this method actually starts to become a coroutine instead of a normal method, and that we yield, and then we wait for another coroutine to complete. So this statement here says, basically tells this method we are going to stop running this code, this method, until this wait for animation coroutine completes. And this is the key to everything. This wait for animation method, which I got straight off the UnityGems website, basically says play this animation here with this certain name until it's 99% complete, and then because we use this yield statement, we go to the next line of code. So this allows us to write very linear code, but actually do a lot of things at the same time. We can, if you didn't have this, you'd have to be calling this method every frame, in update, and just using Boolean statements to say to determine which part of the logic we're in. This is this wait for animation method here. What it does is it keeps you in this while loop. It's another coroutine that basically keeps you in a while loop until you complete the animation, that percentage that you define with the ratio up here. And that's another useful features of coroutines. You can actually have while loops in coroutines. But anyway, after this yield statement returns, so when the animation is 99% complete, we're not firing anymore, but we have to reload because we can only have one rocket in our reload one rocket in our rocket launcher at a time. We play a reloading sound, and then we do exactly the same thing again. We say, okay, wait until you finish playing the reloading animation, and then you say reloading is false. The logic is very, very simple, and it's really all down to this one coroutine here, and I guess it's coroutine, but it makes your life so much easier than if you used, you know, Boolean statements or a finite state machine, or, you know, a switch statement to determine what you're going to do. The final thing that I do here, which will lead on to another thing I'll talk about, which is anonymous methods, is when you disable the weapon, i.e. by changing weapons, and you re-enter, if reloading is still true, so if you're still in between reloading, then I fire off a start a coroutine that waits for the animation, and then I pass something called an anonymous method to it. Or I think, no, it's called a Lambda function now. I think there's a slight difference between the two. And I'll explain what that is in another video, but they're really, really useful. And all this is here is just it's overriding the wait for animation enumerator or coroutine. So that's an example of using coroutines in Unity to make a really simple weapon script. I hope this helps you. I hope you see the worth in it. If you have any questions, just fire them off to me, and I'll see you in the next video. Cheers.